to this, and I think you need to be good at both sides. A, all of these kinds of things, which are all encompassed in your like key takeaways and the summary at the end of your notes, all these things have got to be absolutely rock solid, no negotiating, memorized. At the same time, the why behind all of them should be understood as well. I don't think you can get by with only one or the other. We need to have them memorized, so that takes time and flashcards or whatever. And the other side, the why, you know what that requires? You asking why a lot. Cool. Why is that, though? Well, that's neat. Why? And whether you're asking yourself why, or asking me why, a classmate why, that question needs to be answered. In order for it to be answered, it has to be asked. So please do. All right. So we're going to look at points of inflection, and then we're going to look at one final thing with the second derivative. So a point of inflection, I'm going to give you another one of these like conditional statements. Point of inflection is a location where the concavity of f of x changes, or the concavity changes. I'll just give you a brief illustration of this on a graph. So a classic example would be a cubic. I'll try to emphasize this. I'll try to overemphasize this to make it fairly obvious. Would you guys agree that that's a cubic-ish looking graph? I kind of like the right side better than the left side, but whatever. Would you guys agree with me that the part of the graph that I'm shading in gray, pretty clearly on that part, f is concave down? Do you guys agree with that? Yeah? And then the part that, of course, that I'm shading in blue, pretty clearly is concave up. Conc up. And so f changed from a concave down graph to a concave up graph. So what had to happen in the middle there somewhere?
A point of inflection.
Well said. So if f changes from concave up to down or concave down to up, then somewhere in there, a point of inflection had to have occurred. And for this particular graph, it's right there, right on the origin. It doesn't always happen on the origin, of course, but a point of inflection. That's one way of defining a point of inflection, where f goes from concave down to concave up, or concave up to concave down. It's just a bend in the graph where the graph, it's almost like, isn't it almost like the graph is like trying to turn around a little bit? Like it's going up to the origin, it's like, okay, I'm going to bend back down and like make a parabola or something like that. But then right at the last minute, it's like, oh, okay, I'll just keep going back up. Right? So it's like changed its mind about turning around. Anyways, there are two different ways that you can justify or describe an inflection point beyond what I just said. Here they are. The first one is an inflection point on f happens when f prime changes from increasing to decreasing or decreasing to increasing. And that actually goes pretty well with what we set up here. So, for example, these two right here, this one right here, and this one right here actually goes pretty well with these two definitions. I'd say number 6 and 9 we have up there on the board. The second one here, an inflection point on f happens when f double prime simply changes signs, right? Where f double prime goes from negative to positive. Right? That's where you're going to get another inflection point. So the two that you're going to want to use, the two types of justifications would be the two that I'm starring right here. The one up above is rarely going to be applicable. It is a nice description, but it's rarely going to be applicable as far as the justification goes. One note here, if you have information about f prime, I think you should use the first wording because the first wording has to do with f prime. But if you have information about f or f double prime, we'd probably use that second wording with the emphasis being on probably f double prime. I don't think you'll be getting too many graphs of f for this. Yeah.
Basically, it's just the critical numbers of f prime.
Yeah. But not just the critical numbers. F double prime actually has to change signs.
Okay.
So just setting f double prime equal to 0 isn't going to cut it.
So test it.
You got to actually test and see if f double prime really changes signs. Yep. Well said. And we'll get into some graphs here, and I think you'll see maybe some other good connection with that, Santi. Okay, so I thought I would do example 3 with you, if that's all right, and we'll just kind of explore this. This says, find the points of inflection And then along the way, we can think about the concavity of the graph of f of x. So here would be my suggestion to you. If you are given a graph or information about f, I think we should probably be seeking to use f double prime as our reasoning. I think we can probably do this one without a calculator, so let's try it out really quick. So here's my hope. Because you have these things memorized, and not only memorized, but you understand the why, as soon as you read this, find the inflection points, blah, 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 you're thinking to yourself, oh, inflection points of f, that's going to happen when f double prime does what? And if I'm looking for where f double prime changes signs, I probably ought to have something for f double prime, right? All I have up there is f. How could I actually find f double prime? Yeah, differentiate. So f prime equals, power rule would give me 6x squared minus 6x minus 12. Again, I'm looking for points of inflection. This would be where f double prime changes signs. So I've got f prime, which is neat, but I need f double prime. So how do I get to f double prime if that's what I've got right there? Yeah, just do it again. So f double prime equals 12x minus 6. So it's gotten a little bit simpler as we've differentiated, so that's good. So I'm looking for where f double prime changes signs. What might be like a key feature as to help me find where f double prime changes signs? Yeah, wherever f double prime equals 0. That might be the place where if f double prime is going to change signs, it probably would be there. So I'm going to put equals 0. And again, let me just encourage you that whenever you decide you want to set something equal to 0, whether it's f prime, f double prime, g triple prime, r prime, whatever you decide to set equal to 0, write it down, because if you don't write it down, there really is not an equation for us to solve. Of course, when I do solve this, I get x is equal to 1/2, and that's going to be the place where maybe f double prime changes signs, or maybe not. How do you think I could figure out that f really does, where f double prime really does or doesn't change signs? Yeah, test things out. Are you guys okay with a sign chart? So let's try it out. So I make a little sign chart here. What kind of a sign chart is this? It's an f double prime sign chart. So in the past, we've done f prime sign charts. This one's going to be f double prime. We could just do a sign chart for a lot of things. Here it's f double prime. I'm going to put 1/2 right here. And Anna, you suggested we test out which two numbers?
1 and 2.
How about 1 and 0? You okay with that too? I always like to use 0 if I can. So I'm going to say f double prime of 0 equals what? -6. Yep. And f double prime of 1 would be 6. Okay, so f double prime is negative over here, and f double prime is positive over there. So let's answer the first question. Are there any points of inflection on this graph? Where? That's right, there we go. So we can say f has a point of inflection at x equals 1/2 because f double prime changes from negative to positive.
Do you need to state that you showed like it's greater than or less than in your explanation, or is like having like f prime of 0, f double prime of 0,
Sure.
f prime, double prime of 1 enough?
I think like writing this down here and this down here, I think that's enough. I think we can say, hey, clearly negative number, negative, positive number, positive. If you wanted to bring those in there, obviously it's no problem. But I think having that evidence over there, we can connect that pretty well. F double prime changes from negative to positive at x equals 1/2. And then discussing concavity, we basically have two intervals here. I've got a red interval and I've got a yellow interval. So on the red interval, f is concave what? Why? Well, very true. Did you hear what she said? So I'm going to say it again and just say it a little bit louder because it was really good. Okay, so on the red interval up there from negative infinity to 1/2, f is concave down, Bailey, because?
F prime is decreasing, f double prime is negative.
And I would say the f double prime being negative is the one that we have the most clear evidence for, but the other thing she said is also true. Definitely.
You just need to say 1 though.
Yeah, just say one. Or you can say both as long as they're both right. I tend to think of saying like as little as you possibly can and still saying what you need.
Yeah.
I think is a good practice. So on the yellow interval, F is concave up because F double prime is positive, and if F double prime is positive, then F prime would be increasing. That last part is not necessary at all, but it is true. Okay, questions, comments, concerns? Jane?
Is that the correct answer right now on the board, or do
Yep.
we have to? Okay.
I don't think, so this is in there, it says discuss the concavity of the graph. Like we just verbally discussed that. If this were like a test question, you'd want to write that down too. But we just verbally discussed it. Is that okay? Okay. Yeah, I'll write it down. So F is concave down on the interval negative infinity to 1/2. The reasoning there would be because F double prime is negative on that interval. And then I'll try to squeeze this around the last little bit there. So we'd say F is concave up on the interval 1/2 to infinity because F double prime is positive on that interval. Hey, sort of got it squeezed in there. What do you think, Marguerite? Is that okay?
Yeah.
Okay. Any other questions? Are there any why questions? Yeah, go ahead, Ned.
When we write that, do you want us to write brackets around the 1/2?
Oh, yeah, that's a good question. I'm not going to take off or award credit for correct brackets or parentheses there. Sometimes I get a little bit sloppy with mine as well. Those should probably be brackets, all of them. I'm not going to stress about that, though. Yeah. Go ahead, Heather.
So if we have the first part of the exclamation and then we have the second part, do we have to put because F double prime is less than 0, or do we just put the dot there thing?
So when you say the first part of the explanation, or what are you referring to exactly?
The F has a point of inflection at x equals 1/2 because F double prime changes from negative.
Oh, you're like talking about like could I construct it a little differently?
Yeah.
Definitely, yeah. So like let's talk about just this one right here. Like if you started here where I'm putting the little asterisk, if you started there and you said F double prime changes from negative to positive at x equals 1/2, therefore F has a point of inflection at x equals 1/2?
Kind of.
No?
So with the second part, it's F is concave down on that interval because F double prime is less than 0. If we have the first part, do we have to put because F prime is less than 0, or do you assume that because it says F prime changes from negative to positive?
Okay, I'm a little lost. So are we talking about the thing in the red box or no?
Did I say it no? Never mind.
No, it's okay.
I'll just write it back. I was just wondering if this works.
Or am I missing anything? Because I get a lot of points off on how I write things. So I'm trying to not let that happen this time.
This is good. This is almost exactly like what I wrote.
I just
Right.
don't have the F double prime is less than 0 in the second half of it. Because I assumed that you could tell that from this.
Oh, okay. Gotcha. So I would say you definitely do want that in there.
Okay.
Yes, you definitely do want that in there. Only because in the first one, we were like addressing inflection points.
Mm-hmm.
And I think we'd want to still connect that to like, all right, what does that mean for concave down then? Yeah, a good question. Good question for sure. Try to give as full of an explanation as you can. Don't assume that I'll make the necessary connection back to the thing that makes what you're saying true. Okay. Guys, great questions. What else can I do? All right, cool. Then let's take a look at the next one. I think it's a graph. Yes, it is. Okay. So this will, I don't know, hopefully be a good one for you. It says, given a graph of f prime, determine, and we'll just talk about the x-coordinates here for the inflection points of f, and we want to justify our answer. So just give you a few minutes to talk this one over, get an answer or two down, and see how it goes for you, all right? Shout it out. How many did you find? Two. Two is right. Okay. Can I point out a common error? Hope this is helpful to you guys. I've seen folks take a graph like this and say something along the lines of inflection point at x equals -3 and hey, this is a common error. This is a common error. So an inflection point at x equals -3 and x equals 4. And the reasoning gets a little bit muddy after that. They're like, well, because darn it, it just looks like it, right? F goes from concave down to concave up, right? What mistake are they making? That's a graph of f prime, and they're treating it like a graph of f. So you got to be super careful that you are taking the information in that you're given and dealing with it correctly instead of mislabeling the graph, essentially. Okay, so you guys said that there were 2, and I definitely agree with you on that. So we'll put F has inflection points at x equals what and what? -1 and 2 is correct. Completely agree. So I'm going to say because at x equals -1, what's happening? Any suggestions on a way to justify yourself here?
So relative to n because it changes from decreasing to increasing.
So I like what you said, except you used the word it twice to refer to 2 different things. So let's avoid the use of the word it and try it again. I think you probably know what you're talking about. Let's just use proper names instead of...
Okay, I'll say what I wrote. There's an inflection point at on f at x equals -1 because f prime changes from decreasing to increasing at x -1.
Cool. Okay, that works. At x equals -1. And of course, like you said earlier, that does create a relative minimum on f prime, and that's another big hint. And it's also where f double prime changes signs.
Yeah.
Another big hint. I like the reasoning you gave there using f prime. I think a lot of what you said, if you clean up the whole it thing, I think you're in good shape.
So instead of using f prime, I did f double prime.
Yeah.
Does that still work?
Typically, yes.
Okay.
I think it is best practice to always use the information that you were directly given.
Okay.
You're clearly not wrong, but where we want to be super careful is I'm going to try my best to make sure that you are not using basically like a recipe, like something that you just memorized and sort of like half blindly applied. That makes sense? I want to make sure that you understand. I need to see evidence that you're actually dealing with this question. So if you said f double prime changed signs, and that's all you said, I think we might have an issue. But if you said f double prime changes signs from negative to positive, I think we're talking about the same question. So be careful with that. That make sense?
Yeah.
Okay. Yes, ma'am.
So in this case, decreasing and increasing can be synonymous with negative and positive?
Be careful. So if f prime changes from decreasing to increasing, what that means is f double prime changes from negative to positive. And so again, this is that really scary trap we want to avoid, where we say negative means decreasing. No, it doesn't, depending on what's negative and what's decreasing, right? If f prime is negative, then f is decreasing. But stay out of the habit of saying negative means decreasing. Or negative means concave down. Say f double prime is negative, so f is concave down. Like that's a better way to say it. Yeah.
But it would be correct if I said f double prime changes from negative to positive?
Yeah. It would definitely be correct. If you use that, if you just said f double prime changes signs, that feels like a recipe to me, like something you just sort of memorized, or like right before the quiz, you're like, Eden, what about the whole inflection point thing? And she's like, f double prime changes signs. You're like, okay, I'm going to use that. And you throw it in there, and it just so happens you were right. So it's like an educated guess.
Yeah.
I want to make sure that you're applying your concepts and skills to this question.
Okay.
Okay, so that's the x equals -1. So we're going to say also because at x equals 2, what is f prime doing?
Changes from increasing to decreasing.
There you go. F prime changes from increasing to decreasing. Alternatively, you could say that because f prime changes from increasing to decreasing, f double prime goes from what to what? Positive to negative. You don't have to say that. Certainly not wrong. Certainly be a good justification as well. So you really don't have to give like one justification. You don't have to give like 2 different justifications. I kind of gave 2 different ones in both cases. Yeah.
So this doesn't really have to do anything with the question, but if
It's okay.
f prime, when you're explaining or justifying f prime, there are instances where you use positive and negative?
Sure. Right here. If you've got a critical number at C and f prime goes from positive to negative, then f has a relative mass.
Okay.
Wait, why wouldn't we say changes from increasing to decreasing?
Because f prime is not changing from increasing to decreasing. If f prime changes from positive to negative, remember that f prime is describing the slope of f.
Yeah.
So you could say an f prime changes from positive to negative, therefore the slope of f changes from positive to negative. Now get this, let me connect this for you. Therefore, f changes from increasing to decreasing. So again, it's really easy to get those mixed up. Just be super careful that you don't think of these in snippets, like positive means increasing or negative means concave down. In your brain, when you're saying these things, try to say the whole thing. F double prime changes from negative to positive. Therefore, F has an inflection point at that point, right? Yeah. Name them. Like, it would be weird to talk about this. Like, Audrey, it is nice to see you today in math class, Audrey. I hope, Audrey, that you were having a good day, Audrey, and that your afternoon, Audrey, also goes well. And Audrey, I hope your evening, Audrey, goes well also, Audrey. Like, say the names, like, repeatedly. That makes sense? Don't just say it at the start and be like, yeah, I'll just call it from there on out and we'll be good. We don't really talk that way. Just say, hey, Audrey, how's it going? I hope you have a good day. That's more normal. But think of it like that, like if you just like kept saying the person's name. Have you ever met somebody like that? They keep saying your name. It's a little bit different, right? Nothing wrong with that. Here, there would be a lot right with that. So, guys, great questions. What else can I do? You're coming around. You're not all the way there yet, but you're coming around. We're good? Okay. So let's see what's next. I'm so excited to find out. Hey, there we go. So this is a pretty similar question to what we just did. This will summarize a lot of stuff. Okay? So I want you guys to try ABC. Looking for where the graph is concave up, graph of H is concave up, concave down, inflection points of H. And please note that the graph of H double prime has been given to you. H double prime. So the previous one I gave you F prime and asked information. This one is H double prime. Okay, so let's see how this went for you guys on A. It says identify the intervals on which the graph of H is concave up. Let me explain my hope for you. I hope that as you're reading this and you see, all right, the graph of H is concave up. That's what I'm looking for. I am hoping that as you read that, some options pop up in your mind. Options like this. All right, H will be concave up whenever H prime is increasing. Yeah, so you'd think, okay, cool. I'm looking for that. But then you'd think, all right, ding, there's another one when H double prime is positive, right? So these would be your two options here. And so you think, all right, well, which one of those two do I want to use? Well, doesn't that kind of depend on the data you were given? What kind of data were we given? Yeah, so I'm thinking I want to use this kind of reasoning simply because I was given H double prime. Does that make sense? To me, that would be a more directly reasonable approach. So I'm going to say H is concave up on what interval or intervals? Yep, -4 to -2 and?
3 to 4.
And 3 to 4.
Would it be much wrong if you use the other one?
What do you mean by the other one?
Like if you said that H prime is increasing?
No. But again, I think
It's just more correct.
I think it's best practice to use the data you were given. So we'd say because, and I'm going to say H double prime is positive on those intervals. You can even probably more particularly say that since I use brackets. But again, we're not going to get into the whole open-closed interval thing in our class. Do you guys have those intervals? Did you connect it with H double prime being positive or H prime being increasing? If you did, it's fantastic. Remember, this is not on the quiz, so don't feel like a lot of pressure to just like have this perfected right now. Just do your best and be as good as you can. We'll keep working at this later. Okay. So then B, we'd say H is concave down. And hopefully if you got A, you'd look at B and say, all right, well, if I'm looking for where H double prime is positive on A, on B I'd be looking for where H double prime is negative, yes. Did you guys notice this point right here, how H double prime appears to go to 0 for like one little tiny point right there, like right around 1? So it would be okay to do this. If you wanted to, you could say H double prime is concave, or excuse me, H is concave down on the interval from -2 to 3. You could just group that whole interval there if you wanted to. Or you could say -2 to 1 and 1 to 3. I'd take either one of those. You could split it up into the 2. I kind of like this better because it's quicker.
So that's fine.
I'd take either one. Yep.
Could you split it up into 3?
Could you split it up into 3?
Because I did
Potentially.
2 to 0, 0 to 2, and 2 to 3.
Sure. Yeah.
Um,
I don't see a compelling reason to do that, but if that's what you did, I got no problem with that at all. Yeah. Okay, because H double prime is less than or equal to 0 on those intervals. So the last piece here, I'm hoping that if you got A and you got B right, C would make a lot of sense, right? Identify inflection points. Well, inflection points of H happen whenever H double prime is doing what? Changing from sign, yeah, positive to negative or negative to positive, changing signs. And so we've kind of already outlined that a little bit up above. So how many inflection points did you guys see?
You could say 3 technically.
No, I think
You
only,
couldn't say the Z, like, could you, if you had broken up B, could you argue that?
well, so in order for H to have an inflection point, H double prime has to actually change signs.
Okay.
And right here at this x equals 1, certainly H double prime does equal 0, but H double prime does not change signs, so you couldn't really argue that. It's pretty close, though, obviously. Okay, so you'd say something like H has inflection points at x equals -2 and 3, because I'm going to run out of room here. We'd want to say something like H double prime changes from positive to negative at x equals -2, and H double prime changes from negative to positive at x equals 3. Sorry for the shorthand there, but I'm out of room, obviously. Okay, questions?
When talking about the inflection points, do you have to say that, like, which way the concavity changes from?
Like which way H double prime changes?
Like, do I have to say that it changed from being concave up to concave down?
You said it, I
Do
think.
I have to say that H changes from
Oh.
being concave
You really don't.
down?
So I would think it would be great if you said this, or if you said H prime changes from increasing to decreasing, or the other way around.
But you don't have to add the concavity.
You don't. Listen, honestly, if it helps you, and I realize that for a lot of you, like, we're just trying to get a grip on this, and if that helps you make that connection, do it. Make sure you don't use the word it. It's always dangerous to say those things without using the word it. But that's never wrong, but it's also not required at all. Anyone else? So I, for one, am pretty encouraged. I feel like we're making some progress. I think this is really good. Let me just give you a brief preview of where we're going to finish this. We got one last thing to do. Take a look at number 3 up here, if you guys would. 3 and 8. I'm talking about on the whiteboard right here. 3 and 8. So both 3 and 8 are helping us find relative maxes and mins, right? Using the blank derivative test. First derivative test. We're essentially testing the first derivative. We're saying, hey, first derivative, do you go from positive to negative or negative to positive or neither? And what does that mean, right? So you're going to find that every now and then, and I literally mean this, like sometimes it'll be this way, other times it won't be. Sometimes there's going to be a better tool for the job, and the better tool for the job sometimes will be the second derivative test. So the second derivative test has the same function as the first derivative test. It'll tell us about mins and maxes, but it'll use a different mechanism to tell us that. And in some cases, it's going to be concavity that will be that mechanism. And in some cases, this will be a bit easier than the first derivative test. Other times, the first derivative test is going to be better. So I'm just going to, like this last piece that we'll talk about later on, will just be one more tool for you to have at your disposal. And there will be times when using the second derivative test would save you, like, I'm going to say 10 minutes on a quiz or a test or something versus the first derivative test, simply because sometimes you got to admit the first derivative, okay, you know, fairly easy to find. So other times the second derivative will be super easy to find. Some of these first derivatives we find are super difficult to evaluate. It'd be better to do a second derivative test. I mean, we'll just have to provide some analysis of like, why would this be better? Because you're going to be finding that that's going to be the case sometimes. So that'll be something that we do on Thursday. Thursday, yeah, because Wednesday is our 3-1 to 3-3 quiz. My suggestion for you all is hammer away at the extra practice. The extra practice is so good. It's so good. And I can't even take credit for writing most of it. Most of it I just copied and pasted out of stuff and said, that's a good one, that's a good one, that's a good one. Be super useful for you to do that. If you have any questions on it in the meantime, come see me tomorrow, whatever. Have a great day.
The extra practice, do you have any idea, or
Do I have any